Hi, dear students. This video record is to demonstrate how a bolt-nut type joint can be created for gripping the components two or more. But in this demonstration, I'm going to follow the stages of the shortest way to follow to apply. It is just the method which we use one of the design tools of Inventor. In Inventor environment, yes, we have some facilities. If we use such design facilities, can reach to the end of the studying or model creation stage much more easily at a shorter time. See how. I'm going to use the same example. In the example, yes, there will be in the end two L-shaped prisms connected to each other via bolt-nut type joint. Bolt-nut joint. Okay. The project is the active, still active project. You know, to be able to make the project active, clicked on project steps and then clicked on browse button and then show the address of the project folder, and then in which can find project definition file and select this and then say open. It is already done, so project is active. Okay, I'm going to create the model of the assembly starting from beginning, but passing to the stages of the shortest way to follow. It is going to be a new file. Okay, the model of assembly gonna be in the environment. So assembly template, select unit system in this dialog and then assembly template. Standard, you know, means ISO standards, and then clicked on create button. Yeah, first I'm going to invoke the non-standard components to this assembling environment. How? You know how. Clicked on this listing arrow, and from the list select place option. It is the tool to invoke the models of non-standard components. This click, you know, since the work is a project, the work has been defined as project, you know, it is one of the advantages of making such a definition. When we say open, okay, or when we say create a new file, then Inventor automatically sense that it is the project, and for allowing us to make the necessary selection in the file opening search dialog box, list the files already created available in the project folder. Here it is, the list. Okay, I know that these are the files in which respectively I have the models of the components, component 3, component 4. I selected both of them. How? Clicking on, keeping the control key as toggled on with left clicked on the mouse. I selected both of them and then say open. Or one by one you may select and then invoke. But for saving time, since I need to use both of them, I selected both at the same selection stage, and then yes, I'm going to locate in the assembly creation environment with a clicked arbitrarily first. Okay, press escape button, and then these prisms are to be positioned. I know how. I'm going to use classical constraint tool of Inventor. I know that the surfaces to be positioned are flat surfaces, so this type is the correct type. Okay, solution, if the surfaces are to be directed oriented against each other, face to face oriented, then select this solution. If the surfaces are to be positioned as parallel to each other, select that solution. Here I know the solution is face-to-face contact type solution. So after selecting this solution option and then say that this surface or this prism, click, indicate the surface of the other, click, ought to be in contact, face-to-face. You know, at this stage, if within the offset box we write 0, then indicated surfaces will be in contact. But in some cases it may be necessary to locate the objects at a certain distance, then write into the offset box, for instance 10. Then the surface of the selected components going to be face-to-face positioning, but not in contact, at a distance as it is written 10 meters. But in our case, need to grip them, need to have the surfaces in direct contact. So offset value is 0. Yes, this is a correctly applied mating stage. So clicked on apply button. And then, well, I know that this surface of the component and the surface of the other component ought to be in the same plane, parallel to each other, but in the same plane. Select parallel solution and then indicate the surface. This, click, and the other, click. Since the offset value is 0, then these are going to be in the same plane. Apply. And then similarly, the surface of this prism and that surface of the other prism are to be in the same plane. So indicate both of them with successive clicks and then say that 0. Offset value is 0 and then say, since finish the mating stage, I'm going to click on not apply but OK button. Yes. Then, you know, in the long way, in the previous video record, it is demonstrated how it is applied, how the stages of such a process are passed. After mating the components with respect to each other, positioning them, then created the standard tools. But here in the short way, no need to create those because the holes are created by the software. Okay, you're going to see how, but first save the file at the end of the mating stage. Okay, you know the recommendation, after each stage save file. Okay, start the saving stage, select from here this list, save as option. For the first saving, yes, select save as option to take a right to write the file name. Okay, this is in this example, in this project, the second assembly. So in this regard, I'm going to say assembly 2. But say, let me know who created the file. You know, in school, it is the kind request, write surname, write your ID number, and then section number, etc. Okay, and then I'm going to say this is the second assembly, assembly 2. Okay, and then clicked on save button. Okay, I'm going to change the visualization style to be able to much more easily see the boundaries of the surfaces. For instance, here, although there are two different surfaces, yes, since the reflection angle for the simulated light beams in the environment are the same, this surface and that surface look like as if those were a single surface. Without bringing the cursor onto the surface, cannot see that not one surface, but we have two or more surfaces. But if we change the visualization style from shaded option to shaded with edge option, then Inventor highlights the boundaries of surfaces using thin lines. So, well, thanks to the existence of such a thin line, can easily distinguish that there are two surfaces over there, although the reflection angle for the simulated light beams are the same. I recommend, well, always use the software with this visualization style. Okay, and then the rest. You see along the tab menu bar in assembly environment we have design tab. Well, after clicking on design tab, along the ribbon can find some conveniences. These are in the jargon called wizards. Okay, one of them is to have bolt bolt nut joint or cap screw threaded hole type joint. Okay, this is the push button. Okay, to be able to have a joint indent at a shorter time, relatively with little effort, less effort. Okay, then start the process. Clicked on this button and then see that it is the dialog box. Well, for freshman course may not be so understandable, but when you be third year student, then you're going to see the value of this part of the software. If you use this facility, then you can perform the engineering calculations, necessary engineering calculations for the bolt nut joint or cap screw joint. Well, if the joint going to be bolt nut joint, then select this type. If the joint going to be cap screw and threaded hole joint, well, select this type. In our example, it is bolt nut type joint, so select this one. This selection is to say that, well, the holes are truly extending within both of the components as coaxially created in alignment. Okay, well, the valuable part of the software to use at this stage, but not for this valuable part is not for freshman students, for professionals, graduated engineers, and or also the third year students or senior students. What is that? Calculation tool. If we clicked on this tab at this stage and then perform the engineering calculations, well, into the boxes write the magnitude of forces, okay, and then, well, the safety factor and some other parameters, and then clicked on calculate button and then see which bolt in which size is to be used for connecting the components. Well, with a gripping to grip with a force in the axial direction as equal to that much. Okay. Inventor can answer such questions and output the diameter value for the bolt. Okay. Regarding the magnitude of the forces, those gonna be applied while that object going to be used, and the joint will be under the action of such a loading. Okay, and the other facility is fatigue calculation. Okay, this analysis can be also performed, and Inventor can determine in how many hours, days, or years well, the joint will be, say, because of fatigue, will be broken. Or to be able to prevent the failure as a result of metal fatigue, then what should be the diameter of the bolt? It is the other design question. These are just the questions to deal in design courses. Well, you know, in our curriculum for third year students, we have two successive design courses, machine elements and machine design courses. At that time, you're going to see the value of such a facility. But here, say that assume we perform the calculation and we know that 10 millimeters bolt is the correct bolt to use. Okay. Well, starting plane, this button is on. This means the stage to indicate the starting surface. Indicate the surface to say that the first hole is just the one starts from that surface, and then you see after indicating the surface, starting surface of the hole within the first compartment, then you see existing hole button is on. Well, here, well, this is the option. By hole option is selected, has been selected. If the holes were already created, then yes, we would use this facility saying selecting by hole option. And that's why at this stage Inventor ready for our indication saying that where is the hole. But it is not our case. We didn't create the holes because software can create the standard holes on behalf of us. So from this list, select linear option. When? Why? If you know the linear coordinates, location dimensions for the longitudinal axis of the holes. Okay, and then indicate the starting surface, and then linear H button is on. Well, it is in the order automatically selected, toggled on by the software. Okay, and then indicate the reference entities relative to here with a click indicate. Now this coordinate inputting box is in the screen. The distance from this boundary of the surface to the axis of the hole, say that is 15 millimeters. Write into the box 15 and then clicked on inputting button. The other reference is this edge of the surface, clicked, and well, I remember previous video record, I used the same coordinate value, say 15 millimeters. Relative to here, it is the coordinate of the longitudinal axis. Not only for this hole, but also the other hole. And termination button is on. Well, here to say that hole, not the first but the second hole, both of them well going to be created. Well, the second hole, it is the hole within the other component to have to create, ends at this site on this surface. So indicate the termination surface. Okay, then after passing to such stage, then in the second pane, we find hole icons, and then, well, the size. But here, diameter of the bolt is 12. Not 12. In our example, it is 10. I selected 10. And then the hole diameters are automatically updated by the software. Inventor knows that the standard size of the holes, these are needed to house a standard bolt. It is diameter is 10, is 11 millimeters. It is automatically selected by the software at the background. And then in this pane you see it is written click to add a fastener. Okay, Well, do it. Make a click onto this this bar. After the click, well, program buffer will be routed to the library of the software, standard part library. Okay, if it is for the first time, you use that facility for the first time, then you may need to repeat the click. One more time clicked. It is a trick actually. After the second click, then you find the sub dialog box. Okay. In this dialog, what we have, if from this list the acronym of the standardization association has been selected, in case you decided to use the bolt, it is in accordance with the definition of ISO, then select ISO option. But if you select all option, then while this list selection, the list to select the bolt will be very long. So to be able to shorten the list, okay, well, it is recommended, if you're sure that you're going to use a bolt in accordance with ISO, then select ISO option. You can thereafter start seeing the options from the library of the software. These are all in accordance with the rules of ISO. Okay, from this list, select the type of the bolt, hexagonal head bolt. Then it is another filtering tool. Well, the list is shorter. And then, well, I remember previous example. Not so sure, but I think I selected this type of bolt. For this bolt, the code of the standard code of the document is 4015. I selected this one. Okay. And then one more time make a click onto this bar. Inventor knows that in the order, well, between the head of the bolt and the surface of the component, a washer is used, washer is needed. Well, I selected this type of washer. And then, well, at the end of this list, there is one more bar to click, and it is written click to add a fastener. Well, this bar is to have the components at the other side of the joint. At the other side of the joint, clicked on this bar. Inventor knows the order. Yes, a washer is used. Which kind of washer? This washer, 7090 is the code. And then one more time clicked on this. Okay. And then, inventor knows in the order after the washer nut comes, nut is used. So select the nut, type of the nut from here, and then say, okay, that is it. Yes, answer such questions. Inventor saying that, shall you save the things in the project folder? Say yes, and then see the magic. Yes, you see the joint components and the mating stage, component invoking stage and the component mating stages are achieved at the background by the software on behalf of us. This is the shortest way. But here, well, I see that since I couldn't remember which bolt I selected in the previous example to have its length suitable for this connection, I think I selected the wrong standard, so I have such a undesirable further extension. This extension is too much. So I'm going to change the type of the bolt, because having unnecessarily such a long further extension means waste of material, and also such a unnecessary part will increase the inertia of the object. weight of the object. It is a poor practice, so I'm going to edit it, and also via which can see how the joint it has been created using this wizard. Such a facility can be edited. Well, after applying the process and having the joint, can find this icon, bolt connection icon. It corresponds to this joint. Right click the mouse and then select this option. Well, in the list you see we have delete option. If you made a mistake and by mistake you created such a joint, then you can use this tool to delete it. But here not to delete, but just to change the size of the type of the bolt. Okay, so I'm going to select edit using design accelerator option. It is the thing to do for recalling back the bolt connection dialog box, and then here, well, clicked on this button, say this pane, and then clicking on the triple dot over here, you see there is a button on which there are 3 dots. Okay, it is to invoke the well, the table, but you see since 40 is the minimum length, couldn't find the others here. Say clicked on cancel button and then clicked on this listing arrow. Yes, in the arrow, say after clicking on the arrow, then find the bolt type selection dialog. Instead of selecting 4015, I'm going to try 4016. Since I couldn't remember which one is the correct option or suitable option for having the length of the stem of the bolt at as more suitable, try this one. Okay, it is 45. I see minimum length of the bolt is 45. So try the other, 4018. Not so sure. Yes, yeah, great. Inventor automatically calculated when I selected the say the correct bolt option, and Inventor concluded that for having the joint, okay, sufficiently secure, strong, while the length of the stem can be 30 millimeters. So 30 is the reasonable order. Beforehand it was 40, because for ISO 4015, 40 is the minimum length. But this type of bolt in the market, well, the minimum length I remember is 20, but for our application the length of the stem is to be 30. Inventor at the background calculates, makes such calculations automatically. No need to call the memory on the thickness of the components and the thickness of nut, consider thickness of washer. These are all of those things are done, considered by the software on behalf of us. See the convenience of using the design wizard. And then after making this up to dating, clicked on OK. Now you see the bolt, length of the bolt is in the suitable order. Okay, great. Finish the process. Managed to have the necessary bolt nut joint. Okay, at a shorter time using the design wizard of the software, bolt connection wizard. Okay, save the file one more time. Okay, and then at this point, before saying bye-bye, before finishing this video recording the things, say that if you're going to change computer, okay, For instance, well, you used in the design office the design computer and then continue on the rest at home using your personal computer. Maybe the case. Then you must apply pack and go process to be able to retrieve, gather all the associated files. While we are creating an assembly, model of an assembly, sure, at the background software creates lots of data files, okay, to keep the geometrical relations, constraints, and the types of the components, etc. Those data files are saved in partition C. If you forgot to apply pack and go process and cannot collect the associated data files, have the files in the project folder, then when you attempt to open the assembly of the object using not the same computer but another computer, you vanish. Inventor start to ask lots of questions because the data files will be left in the other computer. And using classroom computers without applying pack and go process, in other words, this means without gathering the data files from partition C into the project folder, if you shut down the computer, since all the data files going to be deleted because of the setting of IT department, well, thereafter it won't be possible to open the assembly file. Okay, so pack and go process must be applied if you're going to change the computer, or if you're using classroom computer and it is the time to shut down the computer. Before shutting down the computer, apply pack and go process. Well, how it is applied? I'm going to answer this question after creating the assembly drawing and editing the assembly drawing. Okay, at that time you're going to see how it is applied. And also, well, I prepared a special video record. It is just to the point about pack and go process. It demonstrates the things to do in applying the pack and go process. How pack and go process is applied. What is pack and go process? In short, can say that pack and go process is the packaging process. It is for collecting all the files into the same address into the project folder. If you watch the next video film, you can see how it is applied. Okay, thank you for your watching, dear students. See you later. Stay healthy. Bye bye.